Hello everyone, and thank you for joining today's session. My name is Reese and I'll be your moderator today. We're going to get started in a couple of minutes. We're just waiting for everyone to join. In the meantime though, please make sure that you've registered for today's session. You can do so by scanning the QR code that's in the top left-hand corner of the screen now. You can also find a link to it in the chat and in the video description as well. Registered for the session and we will send you the recording and the resources as soon as they're available in our resource center, and that should be tomorrow. If you attended yesterday's session, you should also have the recording for that and the resources in your inbox, and it should have arrived about an hour ago. Today's code along, we are going to be working in DataCamp Data Lab. You do not need a premium account to code along with us live. You can do this all on a free account, so long as you have a DataCamp account. If you want to get started and have a quick peek at the slides and at the notebook, they are in the resources document that is pinned in the chat and also in the video description. Also, if you haven't already, please do subscribe to our YouTube channel and drop a like on this video. Helps push it out to people like yourself so that we can spread the learning and get everyone up to speed on AI agents and using Haystack as well. If you have any questions at any point throughout the session, let us know in the chat. We're going to be covering your questions for the last 10 minutes of the session, but also if you're coding along with us live and you have any questions, let us know in the chat and we may stop and help you out and fix any issues. So for anyone that's just joined, welcome and thank you for joining today's code along. My name is Reese and I'll be your moderator. If you haven't done so already, please do register for the session using the QR code on screen now or the links pinned in the chat and in the video description. We also have a resources document that's in the chat and the video description. That will be your main source of content for this session. It includes the workbook that we're going to be working in Data Lab, and it also includes the slides as well as a few other relevant resources that we put together for you as well. So yeah, if you want to code along with us live, please do check out the resources link. If you have any questions throughout the session, let us know in the chat. We're going to be covering your questions for the last 10 minutes of the session. And if you're coding along live, let us know if you have any issues as well, and we can help you get those sorted. With that, I think that's everything from me. I will be sharing a code halfway through the session so that you can get 40% off Data Lab if that's something that interests you. So please do stick around and I will share the code in due course. With that, I will hand over to your host for today's session, Richie. Richie, please take it away.
Actually, I don't know whether my camera's working there. Hold on, let me just switch over cameras. Bear with me a second. Just having a few technical shenanigans here. Okay. There we go. You can actually see me. Wonderful. Sorry about that. Hi there, data scamps and data jamps. This is Richie. And today we are combining two of the hottest ideas in AI right now. So I'm sure you all know that AI agents are basically the biggest story around. And so being able to create agents is about the most marketable skill you can have. So that means today we're going to create one. And secondly, we're also going to learn how to use Haystack. So Haystack is one of the most popular AI development frameworks. So again, an incredibly important skill to have. So combining these two, we're going to be focusing on a use case of a time-consuming but boring task, which is the best kind of thing to automate with AI. So we're going to make an agent to resolve GitHub issues. Apologies to any software developers here who are like, yeah, I really like doing GitHub admin, messing about like resolving issues. Actually, it can occasionally be quite therapeutic, but mostly a little bit tedious. Now, our guest today is exactly the right person for this. So it is Bilge Yücel. She's a developer relations engineer for Haystack at deepset. So that is Bilge spends all day teaching the world how to use Haystack. So welcome, Bilge.
Hi, thank you, Richie. How are you? And how are people joining this session? I'm super excited to be here and talk about like agents, GitHub, and of course, Haystack.
Absolutely. So Bilge is an experienced software engineer turned educator, and her work focuses on building and training a Haystack developer community on GitHub, Discord, and in real life. And before a time at deepset, Bilge was a web developer and at the product development company Hippo. So very well qualified, and please take it away, Bilge.
Yeah, thank you. All right, let's start because we have a lot to cover today. But first, like, AI agents are a big topic. So like these agents can be like hard to understand. So I prepared like a short presentation explaining you what like these things are. So let's go ahead and like talk about that. So my name is Bilge. I work as a developer relations engineer at deepset, which already gave a lot of introduction about me. But if you like to connect on LinkedIn, you can also find me there and we can have a further chat. I don't want to waste my time here like talking about myself. So here's today's agenda. First, we'll talk about like agents and workflows. Then we will see how we can implement those agents in Haystack, and I will show you a real demo of a GitHub issue resolver agent that we are going to build together through data lab, and we will also have some time in the end for question and answering. But I will be happy to answer your questions during the live coding if you're stuck at some point. So feel free to like also send your questions along the way. All right, so agents, workflows, and core concepts. So like in 2025 is the year of agents, and there's not like one definition of what an AI agent is, but here's my definition. An AI agent is a system that autonomously pursues a goal by interacting with its environment and using tools. So basically, the idea behind agents is there's a human input, a query from the user. There's an LLM running behind the scene, and this LLM takes some actions, observes the environment, gets some feedback, takes further actions, or thinks that, okay, this is like this human query is resolved, so I can just stop. So basically you see like there's some sort of a loop, an autonomous system that can decide on its own what to do next. Should it like make another tool call or stop? But like in like past, these systems were quite static, very sequential, very predefined. But right now, it's not the case. Agents kind of make some autonomous things and interact with environment, get some inputs, produces more tool calls, etc. So this brings us back to the AI workflow. So if we know that AI agents, these autonomous systems, what are AI workflows? So an AI workflow is a system that completes predefined tasks by processing inputs through a structured sequence of operations using LLMs. So if you know like there's a deterministic steps, like sequence of steps, and if you know what to do for your tasks, the AI workflow can be a great fit for you, because usually in the AI workflow, you know the steps, you know what to do. Of course, there might be branches. It doesn't have to be linear like this. But in the end, the path, the road is defined, and there's nothing unexpected happening here. For example, like an AI workflow can be a great fit if you have a customer request like service where like there are like requests coming from the customers, and what you need to do is to like summarize these customer requests, put some tags on them, and then like direct them to the right team. Maybe it's the sales, maybe it's customer success team. Like you kind of do it with the AI workflow, and this AI workflow, the steps are defined. There's nothing that needs to be figured out along the way. And when that's the case, you don't need the AI agents. So like if you put them like side to side, AI agents make sense to use if you have a complex multi-step problems requiring diverse actions, or if you need multiple tools or resources to resolve your use case. Maybe your goals are clear, but the path to that goal is not predetermined, so you don't know exactly what to do. Whereas like if your interactions, if you have a very common use case, like such as like question answering, so if you can see the predictable pattern, if you know the task, and if you can decompose them into clear steps, then it makes sense for you to use AI workflows. And on top of that, I think it also boils down to stability, robustness, and efficiency. So if these are important for you, independent from your use case, it makes sense for you to use AI workflows. And it's mainly because, okay, like agents are great systems, but they are quite autonomous. So they can do things that are unpredictable, that are complex. So there are like good sides and bad sides. But like when you give this much autonomy to an AI agent, you also get some risks. And risks are like generating wrong answers, like picking wrong tools, or maybe there is like a very high latency and you don't want to deal with that. So when these things are important to you, so if you need, like, if you're working in a very delicate domain, you might want to use AI agents less and have deterministic AI workflows more. But like, if AI agents are different than AI workflows, how do you kind of achieve that? But it's how, I mean, how you can do that is like choosing an AI agent or choosing an AI workflow is not 0 or 1 decision. You can kind of meet in the middle, and this is actually what we call agentic systems. So it means that you have some agents or agentic behavior in your system, but there are also some deterministic things that you are doing. This is meeting in the middle, and I think this is the best way of taking your application into production, because we don't see autonomous AI agents running on production all the time. They always need some sort of like deterministic steps, or maybe human in the loop. So something that checks what these agents are doing, unless you have this agentic system. In these agentic systems, you can do some undeterministic things, but when it comes to a point, you can say like, okay, thank you, agent. Thank you for your output. I will take it from there and produce the things that I want to do. This is important because we are going to implement our agent in an agentic system. So we will have non-deterministic behavior and deterministic behavior together. Before we go into the details of, before we go into the technical details of this, let's talk about tool calling, because tool calling is core of agentic systems and AI agents as well. So tool calling, you might even heard of it as function calling. Tool calling refers to the ability of a language model to dynamically invoke external functions and APIs as a part of its reasoning process. So if there's a user query coming, LLM can decide to choose the tools, to choose the relevant tool to resolve that query. For example, if the user is asking for what's the weather like in Berlin, the LLM can decide to call the weather API with the Berlin parameters so that it learns about the weather in Berlin. And it can also be for different tasks. The LLM can decide to do multiple tool calls or like sequential tool calls. This is the core of an agent. And if you are working with like very famous large language models out there, most of them are supporting tool calling at this point. So like Anthropic, OpenAI, Gemini, or like other big LLM providers when you think about it. All right, so let's talk about Haystack and how we can implement these systems with Haystack. So Haystack is an open source LLM orchestration framework by deepset. And it provides the tools that Python developers need to build real-world agentic AI systems. And the idea behind Haystack is components and pipelines. Components are a smaller unit. They have one responsibility, such as like creating embeddings, generating text, maybe retrieving information from different data, splitting your files into smaller chunks, etc. So everything that you think as one specific task can be boiled down into a component. And by connecting components to each other, you form pipelines. I will go back to that in a short time. But before that, let's take a look at the Haystack ecosystem. So right now it has more than 21,000 stars on GitHub. It has more than 160 built-in components that you can already start using out of the box. It has 70 integrations. It means that you can use some external tools like monitoring tools, LLM providers, evaluation frameworks out there, and like put it into your pipeline. And if you are just a new beginner, or if you're looking for ways to solve your use case, there are multiple examples, tutorials, and recipes already there in the website. So you can check them ahead and at least like get some ideas of how you can build your application in mind. Okay, now it's the code part. So this is an example component in Haystack. Basically, each component in Haystack is a Python class with the component decorator that comes in the Haystack package. And all you need to do is to define a run function for this component and initialize the inputs and the outputs of this component. So each component, you can think them as the nodes in a graph. And of course, like as a node, it has some input edges and output edges. So you can have like multiple inputs and multiple outputs. The only important thing here is to define their types in your component when you're initializing that, and that's it. And in the component, you can do whatever you want in a very custom way. So each component are implemented like this in Haystack. But if you see that like you have a very custom use case or like very custom logic that you want to do, or maybe there's a tool that you're using internally at your organization, you can go ahead and like build your own custom component and put it into your pipeline. And pipeline in Haystack is actually a directed graph. This means that you can connect these nodes in any way you want. So you can create like your modular application with the component. You can connect the outputs of each node or each component to different components. And you can have like branches, you can merge those branches, you can even have loops in your graph, and it gives you a lot of flexibility when you're building your custom application with Haystack. And here, for example, you see some yellow nodes, and these yellow nodes are custom components. So just like any other component that comes out of the box with Haystack, you can implement your component and put it in your pipeline, in your directed graph, basically. So I will start with a very simple use case. Then we will like implement a more complex pipeline together. So here's an example of a retrieval augmented generation pipeline implemented with Haystack. So imagining that you are using embeddings for your document, the first step here is to have an embedder component that gets the query, user query, creates an embedding by using the models out there and sending it to the retriever. Then retriever can connect to your database, your document store, and retrieve relevant information by using that query embedding. Then we have a third component, prompt builder, that gets the user query and retrieved documents and renders this RAG prompt that we usually use in our applications. And as the last step, we can use a generator component that is your connection to an LLM. This generating component can get the prompt from the prompt builder, basically send it to the LLM and get the response that will be, in the end, the answer of this whole pipeline. So as you see, like each step is covered by a different component, but in the end, it gives you a clear idea of what you are doing in this pipeline. And you can even see what's happening between components. So it's very easy to also like monitor and see what's happening in your pipeline in general. This was the pipeline, and we also have this very special component, agent component. So just like any other component, you can put this agent component in your pipeline and use it in a pipeline, in a RAG pipeline even. But this agent component is more capable than other components that we have out there because it can get the user request and it can connect to multiple tools. So component tool, MCP servers, so through MCP tool, just like regular tools or tool sets, and generate an answer by using these tools. And of course, like maybe something that I need to mention here, of course, this agent uses an LLM under the hood, and this agent is a model agnostic. So you can use Anthropic models, OpenAI models, Gemini models, open source models out there. Basically, the only requirement is that this model that you want to use, or this model provider that you want to use in your agent, needs to support tool calling, and that's it. If tool support is there, then you can use this LLM in your agent, and this can be even a local LLM running through Ollama, for example. Let's take a look at these tool abstractions. So the simple thing that we have is tool. So basically, if you have a Python function, maybe this is like a function that is connecting to an external API, you can easily turn that into a tool. And it's quite easy, flexible, and you don't need to know a lot about what's happening in that tool if you just want to use that abstraction. Then we have component tool. This turns any Haystack component into a tool for an agent. For example, there are like web search components we have in Haystack, or retriever components. You can easily convert these components into tools by using this component tool class. And another tool class that we have is MCP tool. This allows an agent to connect to any tool hosted on an MCP server. So if there's a MCP server running outside, like externally, you can easily connect to that server and use the tools on that server in your Haystack agent by using that abstraction. All right, so this one, till this part, it was about the theory of agents and how we implement stuff with Haystack, but let's see everything now in code. So together we will build a GitHub issue resolver agent. It already has a repository on GitHub. So if you go to github.com, deepset.ai GitHub agent, you see the link on the screen right now, and follow the instructions in README. You can do everything on your own. All you need is a GitHub personal access token and an Anthropic OpenAI, basically an LLM provider API key. Since this is an agent and this is a complex or maybe very functioning agent, the free tier of most of LLM providers is not enough for us. So just keep that in mind, that you might need to have a paid tier to run this agent for yourself. All right, so let me share my other screen and we can start coding together. All right, so this GitHub issue resolver AI agent with Haystack, we are going to use the Anthropic Claude 4 Sonnet model. And what this agent will do is, to giving an issue URL, the agent will fetch and parse the issue description and comments. It will identify the relevant repository, the directories and files. It will retrieve and process the file content and determine the next steps for resolution and post them as a comment. And for this, we will use the agent component that we have. And I already mentioned, I talked about a lot this agent. And the good thing about this agent is you can use it as a standalone component or within a pipeline. And for this one, we will use it in a pipeline. So let me take you through this pipeline. So this is very similar to the RAG pipeline that I showed you previously. So this is a linear one. I don't need to do anything like extra or anything, any loops or branches for this one. So it will in the end have 1, 2, 3 components and 2 tools. Of course, if you like, you can extend the tool list here, provide more tools to your agent. So first, we will have this GitHub issue viewer component. Since we want to implement something modular here, every component will have some specific use case. and we will handle that, and it will handle that on its own. So what this component will do, it will get the issue description and comments of a GitHub issue. Then we will have this GitHub issue builder. It will just render the issue details as a prompt, so that we can pass this prompt to our issue resolver agent. And this issue resolver agent is the agent component that we have in Haystack. It will have access to two tools. One of them is GitHub repository viewer. It will iteratively explore the repository, GitHub repository. And the other tool that we have is GitHub comment writer. It will basically send the generated comment to GitHub. So the idea is, maybe let me share one example an example that we have. So what I did is I forked Haystack repository to my personal account on GitHub. And I have an issue here. So here I want to have print streaming chunk by default in Haystack agents. And here I define what the agent should do. And what we are going to do today is our agent will get this issue description. It will go and explore the Haystack repository, try to understand how it can resolve this feature request and create a plan for us, basically. So, all right, without further ado, let's go back and start implementing. So the first thing that we need to do here is to install Anthropic Haystack and GitHub Haystack packages, because we will use Anthropic Sonnet 4 for our agent, and we will use some GitHub components or GitHub tools for this example, and we already have them as integration. All right, so let's run this cell. It's running. All right. So the next step is to provide the Anthropic API key and GitHub token. So basically, you can get access to your Anthropic API key from your user profile on Anthropic. But if you already have a prepaid account for other LLM providers, you can change the API key name here and use that instead. But just for this one, we will use Anthropic. And for GitHub, I can also show you quickly how you can get that thing. So basically, you go settings, developer settings, and under that, you need to go to tokens classic. And here, by clicking this generate new token, you can generate a new token. Just make sure that it has public repo access if you want to also fork a repository and do this on your own. And once the token is generated, you need to copy it and save it somewhere else. Otherwise, you will lose the token. All right, let's go back here. So I will add my tokens here quickly. So if you use this get pass package, it will ask you your API key, but it will not expose it. So you can easily use it in notebooks or in live streams like that. So I'm just passing the tokens that I have here. All right, so we have our tokens. Next step is to initialize a GitHub issue viewer component. So remember, this was the first component that we needed, and it's already implemented in a Haystack integration as an Haystack integration under this GitHub Haystack package. So I will just import it from that package, and what I need to do is to initialize it. So I say issue viewer and say that GitHub issue viewer, and also what I need to do is to also provide this GitHub token, so this API key to this component. So and the way to do that in Haystack is through secret. So I will say secret from and var and give this name here so that it picks up my token. And what I can do is to then run this component with this example that I have here. So basically, I want to show you how this works, and I can already show you. Let me do that. So imagine we have this issue. It has like lots of comments, like from people. It's a closed one, but it doesn't really matter. We just want to test if this component, so this retrieval information retrieval works as we expected. So I will copy that link and get it here. So what I'll do, I'll just pass it as the URL, and maybe I can say like issue comments here, and we can run this cell. All right, so here you'll see that under this documents key, there's like a list of documents. So 1 document, 2 document, 3 documents. So the first comment, so the issue description is saved as the first document here, and the rest are the issue comments that we have in this issue here. And each document has content, so the issue description or issue comment. Then in the meta, we have type, title, number, state, created at, updated at, author, and URL information. So this will be useful, especially when we are generating the prompt for the agent. And let's go ahead and do that. So if I go back here, so this is check. So we created this component. It was already in the integration. So I will go ahead and create this issue builder component. So in Haystack, prompts can use Jinja syntax. This means that you can have loops in your prompts. You can have if-else statements in your prompt, and this becomes quite handy, especially if you want to get information from different resources and put more than the document content itself. And here's what I mean. So we will pass these documents to the second component that we have, so this prompt builder component, and the prompt template that we are going to use is going to look like this. So it will have this issue from URL, and you'll see that URL here is the prompt variable. Then we will have a for loop running over all documents that are coming from the issue. And if it's the first document, we will put the title that is coming from the meta information of the document. And we will put also each document content here between these issue comment tags. I'm using these tags because for Anthropic, I'm going to use a specific prompt, but that's not necessarily needed for other LLM providers. So since this is my template, I already have one, so I can just create my issue builder component by using the chat prompt builder component that I have as the template. I will use chat message from user. Where's that? So as you know, the way to communicate with LLMs are through messages. So we basically send user messages or system messages and get assistant messages back. So what I'm doing right now is to create a user message. And for that, I will use this issue template, and I need to make it a list. And then I will also have required variables. All this is just to not to get the warning. Basically, this is not mandatory. So let's initialize our issue builder and make sure that everything works fine. All right, so what I can do maybe on top is to, run this thing with the documents that we have here, just to give it a try. I don't need to, but documents, and I will pass the documents cell here and see what we have. Oops, an issue. Oh, URL. Yeah, we forgot about the URL because we have documents variable and URL variable here. So let's add that too. And since this was from this issue, I can just get it here, put it and run it again. Yeah, this should be fine now. Come on. Yeah. All right, so here you see that there is this prompt as a chat message, and in the content you see like issue from, like we use in our prompt, the URL of the issue, and then we see the title, and we see like each issue comment behind these like issue comment tags. Okay, so far what we did is so we created this component and this component. So basically what we do is to, if there's a URL coming, we can go to GitHub, get that issue comments and render that as a nice prompt, like as we want, as we initialized here, and we can pass this information to our agent, and our agent will take care of the rest. Let's go to that step. But before that, we need to initialize the tools that we are going to use for this agent. So the first tool that we need is this GitHub repo viewer tool. What this tool does is like it retrieves content from GitHub repository and based on given repo and path. So basically what it does is it iteratively explores the repo. So it goes through the directory, and if there's another directory, and if it thinks that it needs to go there, it can go into that directory. So it helps us to basically explore every file that we have in the directory. But we don't need to think about its logic because we already have a tool for that. So we can directly use that tool. So what I will do is to repo viewer tool. And don't worry if you feel kind of like lost right now. In the end, it will all make sense. So let me go ahead and hide this. Let's go back and get this GitHub token part here too. Yes. So this is the first tool that our agent is going to use, and we initialized that already. And the other tool that we are going to use is this GitHub issue commenter tool. And for that, I'm going to do something different. There is this tool already available in the GitHub Haystack integration, but I will not use that one just for the sake of this live coding. I will create my own tool for that, and it's going to be a mockup tool. But it's also nice because then you will see how to also like define a tool, like a custom tool. So I will start with the tool decorator, and I will define a function, and it can name as like GitHub issue commenter. This will have like comment as comment parameter as input, and it will return string. And what I will do is I will not do much in this component. I'll just want it to return this comment. So maybe let me go ahead and add a description for that too. For that, I will go back to my notes and put this description. All right. So basically, this is a function, a Python function that I use, and it will just I will turn that into a tool by using this tool decorator, and our agent will use that one as the last step. So if it can come up with a plan to resolve that issue, it will use this tool. And by using this tool definition, I will be able to see what my agent came up with. So this is going to be handy. All right, so I am going to go quite fast from this part. So now that we have tools, we have our components, The missing part is the agent. So for the agent, we need a chat generator and a system prompt. Let's go ahead and create our chat generator. For that, we are going to use Anthropic chat generator. So I'm going to go ahead and initialize that chat generator, and I give a model name here, and our model name can be this, the latest Cloud Sonnet model. Let's do that. Yes. And then as the system prompt, you are free to do anything you want here, but there's already a system prompt coming from this integration, so I will use that one. And if you want to take a look at this system prompt without me making any typos, I'll just copy paste it here, and you see that, like, not like this. Let's see this prompt. Okay, here in this prompt, it's not the whole prompt, but we are instructing our agent to we are saying our agent on like how to explore the repository, how to resolve an issue. It's a pretty long prompt. If you go to the repository of this integration, you can see the full prompt there, and you can also find the link of the prompt here. Okay, so we have our chat generator, we have our system prompt, we have our tools. Let's create this agent in the end. So for an agent, we have like chat generator, system prompt, tools, but we can also define something extra like exit conditions, state schema, and streaming callback. And we are going to initialize them as well because they are going to be handy. So I am going to first provide this chat generator. So this will be the LLM, so the brain of the agent. Then as the system prompt, system prompt, I will go back and get the system prompt coming from this package. As the tools, I will go back. My first tool is this, and the other tool is this repo viewer tool. And then I will define an exit condition. I should put a comma, an exit condition here, and it will be GitHub issue commenter. So what I do is I let my agent to do anything at once. So I will let my agent to explore the repository multiple times by using this repo viewer tool. But when it thinks that it's time to use this GitHub issue commenter, it should stop, because it means that the issue command is already on GitHub, so it doesn't need to do anything further. I define that, then I define the state schema, and it's going to be documents, because documents are actually my issue comments. So I want to say them in state. So I will say that it's a list of document object that we have in Haystack, and streaming callback. Come on. Yeah. Streaming callback is going to be this print streaming chunk. That will allow me to see every tool result, every tool call when they are happening. So let's initialize that. All right. So the last part is to bring them all together and create this whole pipeline. So here's my pipeline. And what I do is I add these components one by one to my pipeline with this add component function. And let's start with the very first component that we initialize, which is issue viewer. Let's go back. Yeah, I say issue viewer. Then I will copy this. I think the second component was issue builder component. Let me double check that. Yes, issue builder component, that this is rendering the issue. And the third one is going to be, let me copy and paste it. The third one is going to be this issue resolver agent. And I will add that. And then so like basically I add these components to my pipeline, but I need to also connect them and define how I want these components to be connected. So issue resolver connect without typos, and I say like, okay, issue viewer component is returning documents, and I want these documents to be connected to the issue builder documents, because remember the prompt was waiting for these documents parameter. Then I know that issue builder is going to render a prompt, so I want the prompt coming from this to go into the issue resolver agent as messages, because my agent is expecting a list of messages as the prompt. There's a small typo here. Okay. So let's run this pipeline. And if you see this message, it means that, okay, at least like the types are fitting, so your pipeline is ready to use. So, okay, this is the exciting part. Now we are going to try this whole pipeline and see if this works. Hopefully it will work. So I have an issue URL that I showed you like previously. I want my agent to like come up with a plan to have this streaming callback function, like streaming callback parameter as print streaming chunk by default. And we will see if the agent will be able to do that. So what I do is I have this issue resolver pipeline, and I will run it with the issue URL that I have. And since I enabled this streaming callback, we'll be able to see the tool calls. So let's run this and cross our fingers. So here we see the thinking process of the agent. So it says that it's a feature request for the Haystack framework. The user wants to enable streaming by default in agents to provide more visibility into tool calls and results, etc., etc. So it also says like how it needs to come up with that plan. So it says like, let me explore the repository to understand how the agent component is currently implemented, where the streaming callback parameter is defined, the print streaming chunk utility function, how streaming currently works in the code base. So this is just like the initial thinking of this agent. And then it makes a tool call, and we see the tool result here. It doesn't allow me to scroll as it's like generating text here, but in the tool result, you see a list of files. It's basically like exploring the Haystack repository right now and coming up with the directories that we have. Okay, so now it's too long to be displayed in full, at least, but to some extent, it's giving us some idea on what our agent is doing, and the cell is still running. So it's because it's trying to explore like the repository. For example, it's looking for the agent component and where this agent component is. It thinks that it's like in this components folder, so it goes there. And for that, it notices this agents folder, so it checks that. So basically, it does a lot of things. And I see that it has stopped now. So, but you see, like the thing is quite huge, because first it explores the content, then it looks at the content itself, tries to come up with a plan, etc. And we won't be able to see the full thing here, but we will be able to see the full thing when we run this cell. Hopefully. All right. Apparently, things didn't work as we expected. So let's see what happened here. What we can do is to check the issue resolver for agent and see if there are any messages. We see the documents. I don't need the documents. Okay, something is wrong here. Let me go back. And see what we have in this result first. So and I noticed that my internet is not doing very well right now. So that might be one thing. A lot of content to debug. Okay, let's see the keys here first. Okay, there is something weird happening here because this should have been more than the agent output. But all right, we'll go with that. And let's see the last message then. This last message. You are right. Okay, then if I do text here, I should be able to see the thing that it came up with, and what I can do maybe nicely is to print this. Okay, so basically what this agent did is to explore the whole repository, and it located the agent.py, so where the agent component lives, and it understood where this print stream chunk function is, came up with the plan, and plan is also here. I mean, it's not exactly what we expected to work, but this is the reason why you need to also be hands-on with the agents. So if you, I believe the solution is already shared with you. So if you go there, you will be able to also see the exact output that we are expecting from this agent. So the idea is basically it needs to explore the repository, check the file contents, and come up with a plan. Now it seems like it stops somewhere in the middle. Probably something is wrong, but that's a thing with live demos, right? So you cannot always trust these LLMs running under the hood. There, especially if they are working on complex tasks, sometimes like they can work in a very unexpected way. But maybe I can show you the exact thing that we were expecting from this by sharing the solution. All right. So what we were expecting from this agent to come up with the idea. So it was observing the current implementation, coming up with benefits of change, implementation of the request, and it was all even like suggesting like testing consideration, and it had this last part like recommendation explaining like why we need to do this feature request, etc., etc. All right. So that was it from me. I know I'm already over time. And if there are any questions, maybe this is a great time to answer those questions.
Wonderful. Thank you, Bilge. That was very cool. I also like the impromptu debugging at the end. It's always nice to see what happens when things go wrong and how do you go about trying to figure out just debugging things and retracing what happened there. So we've got time for a couple of questions from the audience. Before we get to that, I've got a question for you. So it seemed like once you know what you want the agent to do and you can break it down into specific tasks, the writing of the code seems fairly straightforward. I guess the hard part is, how do you decide what are the different steps in the process? Like, how do you go about figuring out what the workflow for the agent should be?
Well, I think first you need to like come up with a plan yourself. And if you see that there's a deterministic part, you can definitely remove that from the agent. For example, for this one, we knew that the input of the system is going to be a URL, and the agent will only be responsible of like consuming the content coming from that issue URL, and that's it. So like I could have just like create like another set of tools and put that into an agent and say it like, if there's like a URL coming, use these tools to get the content of the URL, etc. But since I know that this is going to be like every time, I don't need to like provide it to my agent. So overall, I think like how I can say, like, if you can separate the deterministic behavior from non-deterministic behavior, that's like the biggest thing that you need to do. And like try different things, try edge cases. Like when AI agents work, they are great, but when they don't work, then like it's very hard to debug. That's why like monitoring tools like LangFuse or Arise are quite helpful. When you connect your Haystack pipeline or Haystack agent to those tools, they help you to see like what's happening under the hood. Because like when there are a lot of tool calls, when there are a lot of like thinking process happening, when agent is working internally, you don't know what's going on there unless you're using like monitoring tools. Of course, like you can use streaming to help you when you're developing, but as you saw, like for example, in this editor, it cut off after like 1,000 characters, which is like not always handy.
Yeah, there's maybe the last point is maybe like a feature request for the data lab team. Just provide more than 1,000 character output. All right, so it sounds like I guess the takeaway here is that reasoning is quite expensive. Thinking about what you should do is difficult. So you want to try and narrow the scope as much as possible, and then break things down to smaller steps, and only make the AI, the agent part, do simple things and do as much deterministic stuff separately with other tools.
Yeah, exactly. And also one thing I need to remind everybody here is like, if you're working with agents, don't use like products out there. Like, I mean, in a way that, for example, when we are using this agent, I forked the Haystack repository. I didn't want to use my own personal token. I created another account and used the token for that one. So like when you are giving access to production to those agents, be mindful, like test it with like forks and mockups or staging environments first. Like this is quite important, especially if you're providing this right access to those agents.
Yes, definitely. Testing stuff before you release it into the wild seems very useful. And can you just talk me through about cost control as well? I don't know, how much did it cost to run this agent like once through?
So like for this one, it costed like 30 cents, I believe. And it's in the end made a lot of tool calls because it was trying to like explore the whole repository. So like this is like a very heavy task, I would say. So 30 cents is again like a reasonable amount of money for this task, I would say.
Yeah. So in this case, you probably want to only use an agent for tasks that are going to take up a lot of time for a human. Then, like if it's just something you can solve in in a few seconds, then don't bother with it.
Exactly. Like imagine that it runs for almost 2 minutes, and in those 2 minutes it makes a lot of like calls and thinking. Of course, like there are ways to optimize that, but like when you're doing like when you just started to work with agents, I think like you kind of like it takes some time to optimize everything. First you need to like make it work, then you start optimizing it.
All right, super. So we've got time for a couple of audience questions. Before we get to that, I was going to say we've got the Radar conference coming up on June 26th. Please do register for that if you haven't already. It's one of the biggest events of the year. We've got a whole day talking about AI with some of the top experts around the world. There's a link in the chat. There is a QR code on the screen to sign up for it. I'll just say I am going to be back tomorrow for a webinar on the DataCamp quarterly roadmap. So you find out what's just been happening with DataCamp and what's coming soon. And then next Tuesday, we have a session on building and evaluating RAG pipelines. So also sort of agent related. Retrieval augmented generation is another incredibly important skill to learn about. So please do come back for that. All right, with that, let's go to some questions. So Peter had a question about this is when you were presenting the slides. So why do we need to embed the query again in the retriever if it's already been embedded once beforehand?
Oh yeah, great question. So when you embed, the things that you embed are actually your documents. So you don't embed the query. First, you create embeddings for your documents. You put it into your document store to your database. So wherever you're storing your information. And then, of course, to calculate the similarity, you need to create an embedding for your query as well. Because you can index your documents anytime, but query is coming in during runtime. So you need to create another embedding, calculate the similarity, retrieve most similar 5 documents, 10 documents, 50 documents. This is a setting that you need to define, and then do retrieval. Hope that answers Peter's questions. So basically, it's the difference between indexing and query.
Okay, yes. If you want to see how similar or different 2 bits of text are, you got to convert them both into matrices, so you can measure the distance there. So you need to do it with your documents and with your query, so they're in the same kind of number format. All right, nice. There was one more related question. So this comes from Enes. So when you're showing the different tools that are used, it looked like there's no support for Google embedding within Haystack. Is that the case or not?
Good question. I'm not sure. I think there's support for Google embeddings. Yes, but I need to check that. But if you want, you can also go ahead and check it out by going into haystack.deepset.ai/integration. So if you go to Haystack website, you will see the integrations tab, and there we have a list of every integration that we have, every component that we have. You can definitely see that. But I think there's support for Google embedders.
Okay, so it sounds like it's probably there, or at least coming soon. Go and check out the documentation. All right, super. Thank you so much for that, Bilge. That was very, very cool stuff. A lot of fun. Thanks.
Thank you.
All right, cheers. And thank you to everyone in the audience who asked a question. Thank you to everyone who showed up today. Remember, register for Radar and